a few things also that I want to mention is when I was first introduced to the problem, they gave me some sample data, and I opened Python and I started coding it. I solved the problem. I was very happy to see the closed loop, but that's not enough. So one thing that I really had to work hard on was, how do you go about now writing professional code, right? How do you go about learning how to do version control? It's really neat that I wrote the code that is going to be running on every beam pump in the company. But if something goes wrong with that code, it's on me, right? So also learning about accountability was very important. And so that's something that has stuck with me ever since. Here's another problem. This was actually the first problem that I worked on. So everybody's familiar with the shale revolution, I think. And the basic idea behind the shale revolution is that we moved on to shale rock, which is much tighter. It has, it doesn't conduct as well. And so you can't just drill a hole and expect oil and gas and water to flow out. So that's why we came up with hydraulic fracturing. And one big problem is that you like to figure out how to drill your well, how to configure it, how to complete it, as they call it in the industry. So how long should the lateral section be? How many stages, which are these sections where you do the shots, how many should you do? How much fluid should you use? How much proppant should you use? There's so many configurations. At what rate should you pump your fluid? And then how do you tie that to the rock where you are? And then ultimately what you want to know is if you're going to have a good performing well. So you have to come up with a good metric for measuring the performance of the well. That could be cumulative production in 90 days, could be something else, could be profit. And so if you want to come up with a problem, like in the previous example from first principles, you're going to end up with a very complicated system now, right? So now you have to tie, a lot more things, and there's a lot more uncertainty. It's not like in the previous problem where we have a dynamometer attached to every well, and we're measuring good data for that system, for that pumping unit. Here, there's a lot of uncertainty. There's a lot of lumping of data. So it's a little bit different. So the next best thing that you can do was apply machine learning, right? And if the dynamics of the system were easy enough, I think you would be able to observe it from the data. But the truth is that nobody truly knows what these relationships and how these interactions are tied to production. And so the basic setup is you have completions, you have some input for how your frac job is going to be done. You have some inputs about the geology, about the composition of the rock, how deep, so on and so forth. And your output is what you're producing. And what you want to know is you want to learn what is the relationship between this input and this output. So that's the setup for performing regression in this case. And that was the first problem that I was given here. And then once you have a model, once you go through the process of rigorously coming up with a model that best, predicts the performance of a new well, then you can start to formulate what you want to do with that model. So it's not enough to say, I built a model, I have some black box that gives you input output. You got to solve an actual engineering problem. So one typical thing that people do in the industry is they say, I'm going to fix how I'm going to do the job. And then I'm going to basically do a sensitivity over your assets. And maybe you have some other model that tells you something about the geology of the region, of the bench or the zone that you are, the layer of rock you want to place your well. And you want to know if there's a location that is going to give you a high likelihood of having a good performing well. So that's what they call a sweet spot mapping. And so that can be done. the other way is the reverse. Now you basically know where you want to land your well, and that infers the type of geology that you have. And then you want to optimize your completion. Maybe you want to perform some sort of a cost constraint optimization and maximize your production or maximize your profit, so on and so forth. And one thing that was, I had never done in practice is how do you go about doing this sort of thing in a situation where you have no gradient. So that was the new thing that I had to get more familiar with. The main lesson here for me was, maybe this is a little bit of a counterintuitive advice that you might hear is, I had to learn machine learning. There was a lot of statistics that it wasn't my strong suit. Learning theory, programming, so on and so forth. The list goes on. And so that was kind of daunting. And then I was thinking, was there something that I should have learned back when I was in school? Maybe I should have taken more courses in statistics. Maybe I should have taken more courses in programming. Maybe I should have learned a particular language. But my advice is actually don't worry about it. I think my background in mathematics and working on something that I was enjoying. So I was working on control theory, solving PDEs, showing some controllability properties of some system. That's what I was doing, and that's what I was enjoying. And that was the best decision at the time. When I came to my job and I had to learn these two things, that's, if you're familiar with the concept, there's this idea of skin in the game. I had skin in the game. My job was on the line, right? So I had to learn it, but I had the basic skills. I had the base to be confident and say, if I just pick up a book, there's no book that is too difficult for me to pick up, right? And so I think that was the right mentality, and I don't regret doing things differently, to be honest. Now, if you really want to take more courses in statistics because you observe that in industry this is a very valuable skill, that's 100% the case. I think it's very valuable, and it's definitely something that you will use at one point or another. But I would not worry too much, and I wouldn't make it a priority. I think the priority when you're in school is learning something with passion, doing it very well, and if you go about that route, there's no book that you can't pick up. So that's what I take from this particular project. Another thing that was useful for me to learn at the time is this was the first situation where I had to explain some of these terms to my collaborators, and so I had to be on presentations and basically showcase my results, and I had to learn what to communicate these results. Not so much I wanted to show what I did, but how it was bringing value to the company. So it wasn't so much that I built some machine learning model. Most people don't really care about that step. It's good that you do it right, but the most important thing is how does it bring value to the company? Same as in the previous example, I wasn't telling anybody that I was having fun solving some PDE. It was more like, this is gonna really save the company money, because ultimately that's the goal. Okay, so then the next thing I want to share with everybody is what I'm calling this good environment detection system, so to speak. I remember when I first got a job and I knew I was coming to Oxy, I went on Google Maps and I saw this picture of the building, and it was kind of daunting because there was a lot of uncertainty. And throughout the years here, I've been here about 3 years, I think of my day-to-day as quote unquote being in a simulation. And what I mean by that is that, I go about my day. If you're familiar with this idea of object-oriented programming, you have a CASA concept, and then you have an ISA. And I think of myself, as an individual with mathematical background, problem-solving skills. That's my ISA. That's the base of everything that I do. And everything else is a HASA, is an attribute to the class Jesus, right? And so I go about my days trying to pick up attributes, trying to come up with new things I can pick up and discard if I need to. And I can, this is a good way to kind of, I think it's a good analogy in my opinion to debug yourself and tune yourself at every turn, because there will be mistakes that you make. There will be a lot of debugging of your personality, of your technical skills. You will for sure encounter this situation. And another thing that I find very valuable is, of course, you can't really choose who is going to be in your team, but one thing that I try to find in the people that I network with and that I collaborate with very closely is, I want to be surrounded by people who are high intelligence because I want to be better at my job. I want these people to be high energy because I want them to be motivated, and I want them to, I want them to transmit that energy to me. And I want them to have high integrity because at the end of the day, these people are the people that have my back. You know, when things get rough, I don't want them to backstab me. So understanding who are these people of high intelligence, energy, and integrity, I think is very crucial. And I feel very fortunate that I'm in a team that that has all these traits, for sure. And that's gonna make yourself develop confidence more easily. Another thing is that I think a lot about is, what sort of reputation do you want to have? So I definitely want people to think of myself as somebody who has technical skills, but I also want them to think that I have these same traits. I want them to think that I have high intelligence, that I'm very motivated, that if I'm asked a question, I'm going to put in the time and the energy to solve the problem. So that's going to make them, that's going to make myself be perceived as a very good team player, and to have high integrity. I'm not going to go and take credit from other people, right? I'm going to always give credit where it's due. Last thing, one thing that dawned on me very early on is that I work with a lot of engineers, and if you end up in a graduate program like me, you're going to be teaching a lot of engineers. You're going to be teaching calculus to a lot of engineers. And so one thing that dawned on me is that these kind of were my students, right, at some point, but now they're my close collaborators. So their success is my success, and I got to treat them with respect. And I have to always keep in mind that they know a lot of things that I can benefit from. And so that was very valuable for sure. And those are the lessons that I want to share with you guys. Readings. This one it's just a few books that I picked up ever since I joined and that have made a big impression on me. The first one that I want to recommend is this red book, Statistical Rethinking. That one made a really big impact on my education at the company, because I was always very focused on maybe PDE theory, and I didn't have much of a, the emphasis of this book is to kind of reteach you statistics. And so a lot of concepts about how you go about thinking about data and how do you pose a problem when you have data, that was very insightful. The second book, Understanding Machine Learning, I believe one of the authors, Ben David, was at Waterloo. I don't know if maybe Oscar. Yeah. Yeah, now I think they're in Israel, both of them now. But this is a book that it's a lot more theoretical, geared towards machine learning. So that was very, very useful. And you can find lectures on YouTube. And the third one is kind of a Bible, general Bible by Murphy. I think a lot of people know it. Artificial intelligence, just, I think, concepts on computer science are, can really come in very handy. And that sort of mindset can be very handy. Some that are not technical is this one by Scott Adams. I don't know if anybody's familiar with this guy.